As we continue to push the boundaries of modern engineering and construction, it's not surprising that advancements are being made in all areas of the built environment, including one of the most ubiquitous and essential modes of transport, the elevator. While the basic principles of these vertical transportation systems have remained constant since their invention in 1853, manufacturers are constantly working to make them more efficient, more intelligent, and more sustainable. In fact, some of the world's leading elevator manufacturers are investing heavily in advanced research facilities to develop the next generation of elevators. One such facility is a secret underground lab located in Scandinavia, where leading manufacturers are working on groundbreaking innovations that will change the way we travel in and around tall buildings. The fruits of their labor include a revolutionary flat carbon fiber cable that could replace the traditional steel cables used in elevators, leading to significant improvements in efficiency, durability, and passenger comfort. But how does this cutting-edge cable work, and what are the benefits of using it over conventional steel cables? And why are manufacturers investing so much time and money into developing this new technology? Join us as we explore the fascinating world of elevator engineering and discover how the humble cable is being transformed for the 21st century. The journey to the top floor of a skyscraper or the basement of an underground car park is something most of us take for granted. However, the engineering marvels that make this possible are often overlooked. Elevators are one of the most important inventions of the Industrial Revolution and have become an indispensable part of modern life. Today, billions of people around the world rely on elevators to move them safely and efficiently from one floor to another. The key to this innovation is the use of a flat cable instead of the traditional round cables used in steel elevators. The flat cable is lighter, more elastic, and has an anti-abrasive surface, which allows it to be used in higher and faster elevators than ever before. For example, in Shanghai, there is a 192-meter high residential tower called the Shanghai Tower, which uses a thyssenkrupp elevator that travels at a speed of 18 meters per second. This speed is made possible by the flat cable, which can withstand the immense tension and compression forces involved in such high-speed travel. One of the biggest advantages of the carbon fiber cable is its lighter weight compared to traditional steel cables of equal strength. The average weight of a steel cable used in elevators is about 5 kilograms per meter, while the carbon fiber cable weighs just 1.5 kilograms per meter. This significant reduction in weight means that less energy is required to move the elevator, resulting in substantial savings in electricity costs. Additionally, the flat cable's elasticity allows it to absorb and release energy more efficiently, further reducing the amount of energy needed to operate the elevator. The traditional steel cables used in elevators have a limited lifespan due to factors such as wear and tear, corrosion, and fatigue. However, the carbon fiber cables have an estimated lifespan of up to 40 years, double that of steel cables. This extended lifespan means that the cables need to be replaced less frequently, which can lead to significant cost savings over the lifetime of the building. Moreover, the anti-abrasive surface of the flat cable reduces the risk of damage during installation and operation, further enhancing its durability. When it comes to transporting large numbers of people, safety is of paramount importance. In emergencies such as a fire, the elevator's ability to evacuate passengers quickly and efficiently can be crucial. The flat cable's lightweight and high strength make it easier to dismantle and remove in case of an emergency, allowing for faster evacuation of the elevator shaft. Additionally, the cable's durability and resistance to wear and tear reduce the risk of catastrophic failures, enhancing the overall safety of the elevator system. However, the benefits of the carbon fiber cable don't end there. Its use also improves the ride experience for passengers in several ways. The cable's ability to absorb and dampen vibrations reduces the jolts and bumps commonly associated with elevator travel, providing a smoother and more comfortable ride. Additionally, the flat cable's enhanced stability reduces the risk of tilt and sway, which can occur in tall buildings, particularly in windy conditions. This is achieved through the cable's unique design, which optimizes the distribution of weight and balance, resulting in a more stable and secure ride for passengers. To illustrate this advantage, consider the iconic Burj Khalifa in Dubai, the tallest building in the world. At 830 meters high, the Burj Khalifa has multiple elevators that transport visitors to the observation deck at the top. In such a tall building, the issue of stability becomes particularly important, especially in windy conditions. The traditional steel cables used in elevators can be susceptible to wind-induced vibrations and sway, which can make the ride uncomfortable and even dangerous. However, the carbon fiber cables used in the Burj Khalifa's elevators are able to minimize these effects, providing passengers with a smooth and stable ride even in the highest floors. The introduction of carbon fiber cables has allowed elevator manufacturers to create taller, faster, and more efficient elevators than ever before. For example, the thyssenkrupp company has developed the world's fastest elevator, which travels at an astonishing speed of 7 meters per second. This is made possible by the use of a flat carbon fiber cable that can support the immense weight of the elevator car and ensure its stability at high speeds. Another benefit of the carbon fiber cables is their resistance to environmental factors such as corrosion and UV radiation. This makes them an ideal choice for buildings in coastal areas or regions with high levels of pollution, where traditional steel cables may deteriorate more quickly. Additionally, the cable's lightweight nature reduces the load on the building's structure, allowing for more flexible design options and potentially reducing the need for additional support systems. Despite the numerous advantages of carbon fiber cables, it's important to note that they also come with some challenges. One of the main challenges is the cost, as carbon fiber is generally more expensive than steel. However, the long-term cost savings associated with reduced energy consumption, maintenance and replacement expenses can offset the initial investment. Another challenge is the difficulty in manufacturing high-quality carbon fiber cables due to the complex weaving patterns involved in their construction. However, advancements in manufacturing techniques and automation are helping to overcome this challenge and make the cables more widely available. Overall, the use of carbon fiber cables in elevators represents a significant advancement in elevator technology. Their superior strength, durability, elasticity and stability offer numerous benefits over traditional steel cables, making them an attractive option for building owners and developers. As elevator manufacturers continue to innovate and improve their designs, we can expect to see taller, faster, and more efficient elevators that enhance our everyday lives. Carbon fiber reinforced polymers, or CFRPs, are engineered materials that combine the high strength and stiffness of carbon fiber with the durability and toughness of polymer matrices. These materials are created through a process that involves impregnating carbon fiber with a resin, which can be a thermoplastic or thermoset, and then curing the material to create a strong, lightweight composite. CFRPs have a wide range of applications in various industries, including aerospace, automotive, construction, and sports equipment. In the elevator industry, CFRPs are gaining popularity as a viable alternative to traditional steel cables due to their exceptional properties. CFRP cables are lighter, stronger, and more durable than steel cables of comparable strength, making them ideal for use in high-rise buildings where weight is a critical consideration. Additionally, CFRP cables are highly resistant to corrosion and environmental degradation, ensuring a longer service life and reducing maintenance costs. Their high stiffness and low thermal expansion also make them suitable for use in extreme temperatures, expanding their potential applications. One of the primary advantages of CFRP cables in elevators is the improved energy efficiency they provide. The lightweight nature of these cables reduces the overall weight of the elevator system, leading to lower energy consumption and cost savings over time. Furthermore, CFRP cables exhibit excellent fatigue resistance, allowing them to withstand repeated stress cycles without significant degradation, enhancing the reliability and safety of the elevator system. While CFRP cables offer numerous benefits, they also face challenges such as higher initial costs compared to steel cables and the complexity of their manufacturing process. However, ongoing research and development efforts are focused on improving the cost-effectiveness and production efficiency of these cables, making them a more attractive option for the elevator industry. Looking ahead, the future of elevator technology is bright, with exciting advancements on the horizon. One notable development is the integration of artificial intelligence, or AI, in elevator systems. AI-powered elevators can learn from user patterns and optimize their performance accordingly, providing a more efficient and personalized experience. These smart elevators can also adapt to real-time conditions, such as adjusting the temperature based on passenger needs and occupancy levels. Another exciting development is the use of regenerative braking in elevators. This technology captures the energy generated during braking and stores it for use during subsequent operations, reducing energy consumption and costs. Regenerative braking is already being implemented in some modern elevators, contributing to a more sustainable and eco-friendly transportation system. Moreover, advancements in materials science are leading to the development of stronger, lighter, and more durable elevator components. For example, the use of high-performance alloys and composites is enhancing the strength and longevity of elevator cables and other critical parts. These materials also offer excellent resistance to corrosion and environmental factors, ensuring the safety and reliability of elevator systems. In conclusion, the future of elevators holds great promise with innovations such as AI integration and regenerative braking on the horizon. These advancements are poised to transform the way we use elevators, making them smarter, more efficient, and environmentally friendly. As technology continues to evolve, we can expect even more exciting developments in elevator engineering, ensuring that these essential systems continue to serve us well for generations to come.